Okay, this last section is called distributive practice. That basically means review. So it's anything from chapter 1, 2, and 3. So this one, it looks like it's composition of functions. F of g of x basically means you're going to put one problem into the other. And I don't really like seeing this. It's too fancy for me. So what I do is I write f, and I figure out what g of x was equal to. It says over here it was equal to x plus 3. So now for me, that's a lot easier to comprehend. It's saying put x plus 3 into the f problem every single spot you see an x. So we've got -2, parentheses, squared minus 1. So we're going to stick in x plus 3. Now the biggest mistake people make is they try to distribute the -2, or they try to distribute the exponent. That's all wrong. You have to do order of operations. So you got to do PEMDAS first. PEMDAS states to do x plus 3 first, because we have to do the exponent first. So x plus 3, x plus 3. This ends up, if you show all the work and simplify it, it's going to end up saying x squared plus 6x plus 9. Now that's all in parentheses still, and then we have the -2 in front, and we have the -1 at the end. So according to PEMDAS, we have to now distribute, and then at the end it's all just adding and subtracting. So this is -2x squared minus 12x minus 18 minus 1, and then at the end these two go together. So the final answer is -2x squared minus 12x minus 19. That's our answer. The second problem is basically a two-step problem. So this is what we do first. So we do that first, and once we get that answer, then we plug it into this one second. So that's what we do second. So g of 7 is first. G of -7, sorry. So g is x plus 3, so this really means -7 plus 3. So the answer to that is -4. So now we take that and we put that into the f problem. So we're going to do f of that result. So f of -4 equals, see, the problem says -2 parentheses squared minus 1. So then we just put the -4 on the inside. And again, following the order of operations, or you could just type the whole thing in the calculator, but if you follow the order of operations, you have to square the -4 first, giving you a positive 16. Positive 16 times -2 is -32, and then you just subtract 1. So the final answer, the ultimate answer, is this guy right here, -33. The next question, pretty much the same, just backwards. So it looks like they want us to plug in the f of x into the g problem. So I think f of x was equal to what was it? I forgot. I think it was -2x squared plus minus 1. So I'm going to write g of -2x squared minus 1. And the f, or the g problem, is x plus 3. So we want that stuff in here and add 3 to it. So we put -2x squared minus 1. Now, there's nothing really to simplify here, so we can just take off the parentheses. I mean, there is a 1, and if you distribute it, it's the same thing anyways. So we got plus 3. These two go together, so the final answer is -2x squared plus 2. There's your answer. The next one says find f of 3 first, and then once you get that result, put that into the g problem. So f of 3 is going to equal -2 squared minus 1, so we plug in the 3. So that ends up being 9 times -2 is -18. -18 minus 1 is -19. This is our result for the first part. So now we go into the g problem, and we plug in -19, which I believe the g problem was just x minus 3. So something minus 3, plug in our -19, so we end up with -22. This is our ultimate answer. Next part is about inverse. So anytime you do inverses, you have to switch the x and the y. So what I do is I change f of x into y, since that's what it means anyways. And then I literally just switch the x and the y. So x, y. Everything else stays the same. Equals, parentheses, with the -1 inside, squared out here, plus 1. So now we just have to get the y by itself. First, we subtract 4 from both sides. So this is x minus 4 equals y minus 1 squared. To get the y out of there, we have to square root the entire set of parentheses. So we go like this to both sides. the square root and the square cancel each other, so we're left with y minus 1 equals, actually it should be plus or minus square root of x minus 4. And then the last step is to just add 1 to both sides. So our final answer, instead of the y, I'm going to put f of x back with the little inverse symbol, which looks like an exponent of -1. So it equals, whoops, I don't like the way that looks. It equals plus or minus square root x minus 4, and then plus 1 on the outside. Same thing to the next one, except this one already has the radical. So we got cube root x minus 9 minus 2. So again, switch the x and the y. Everything else stays exactly the same. Cube root, minus 9 in here, and then minus 2. So we're going to solve this basically in the same order. So add 2 to both sides. So those cross out. So we have cube root y minus 9 equals x plus 2. And then to undo the cube root, we have to raise this to the third power. So we raise this to the third power. The third power cancels out the cube root because they're inverses of each other. And we actually don't have to multiply this out. We could just leave it like that, and then we would just add 9 to both sides. So these cross out. Switch that y back into f of x. So I put f -1 of x equals x plus 2 cubed plus 9. There's our final answer. I think there's some graphs somewhere around here, maybe. Nope, just kidding. Now, let me just say also, if we had to do the inverse of a graph, all we would do is make a list of all the points, x1, y1, x2, y2. So we would find as many points as we could find, and then to do the inverse, all we would do is switch them. And I'm not talking about signs, I mean literally switch the order. So it'd be y1 and then x1. Because all we're doing is taking the two numbers and reversing them. And then we replot them and we should be good to go. It'll create the shape. Key features. So zeros. Zeros are on the x-axis. So we have the zeros here and here. So one of them is at -2, 0. The next one is at +1, 0. And again, they're called zeros because the second number is always 0. End behavior. When it comes to end behavior, this is saying the left side, and this is saying the right side. And we just want to know where are the y's headed. Usually these are always going up or always going down. So if we focus on the left end has an arrow pointing up. So that's headed towards positive infinity, and you don't have to put the positive sign. The right side is heading down, so that's headed towards negative infinity. That's typically how you do those. So get rid of that stuff. Let's see, domain. Domain is off the x-axis, so negative infinity is off this way, positive infinity is off that way. And in my class, a lot of people think that the domain is from -3 to like 1. But the fact is, this graph continues to go left forever, and even though it's almost vertical here, it's going to go to the right forever also. So your domain for these is going to be negative infinity to infinity. And I also tell my class, like, if you don't know what it is, just put negative infinity to infinity. There's a lot of shapes that have that for the domain and for the range. So if you have no clue, just pick that. For the range is off the y-axis. So negative infinity would be down here. Positive infinity would be up here. We're looking for the lowest and the highest. The lowest looks like the graph is headed towards negative infinity. And the highest, even though we've got this hump here, this graph actually passes it. So it heads off to positive infinity also. And we never put brackets on infinities. Now for my favorite part, increase and decrease. When it comes to increase and decrease, it's all right off of the x-axis. So we've got positive infinity over here, negative infinity here. And what we're looking for is where the graph is changing directions. So this graph, it's changing directions right here. That's at -2. And then it changes directions the second time right here at 0. And basically what we have here is we have the intervals where the graph is increasing and decreasing. So this red section is decreasing. This blue section is increasing. And this red section is decreasing. So for my increasing interval, it's just the blue part. So that goes from -2 to 0. And we only use parentheses on these because The only time we ever use brackets is on domain and range if we have numbers or endpoints that have black dots. So everything else uses regular parentheses. Now for decreasing, we've got two sections. We're going to come from negative infinity to -2. And then there's a break in the graph, so we put union. And then we're going to start up, head downward at 0, and we're going to head over to positive infinity. So from 0 to infinity is the second. And that's pretty much the entire review. So hopefully you guys are using this, and hopefully it helps.